In this video, you'll see how to use Pasco Science Workshop to take a fast Fourier transform of a sound sample. So we've just opened the Pasco interface on the computer. And first we need to select our sound sensor as our hardware. So in hardware setup, depending on which port you have your sound sensor plugged into, you'll either select A, B, or C here. Our sound sensor is plugged into port A, so we're going to find the sound sensor from the drop-down menu, select it. And you can see here it's green, meaning that your hardware is all ready to go. And now we're going to navigate over here to the fast Fourier transform option for our display. And if we click here, double click, you'll see you now have a graph with frequency on the x-axis, but you have to select measurement, sound intensity for your y-axis. And now it's important to make sure that your sampling rate is correct. We only need to be at around 2.5 kilohertz for the sound sensor to work. At 200 kilohertz, the sound sensor will be unable to record a fast Fourier transform. So now, if we hit record, we can see a fast Fourier transform of whatever sound is in the background. So first we're going to use a wind pipe. We're going to play it in front of the sound sensor, and we're going to see the fast Fourier transform of the sound that's produced. You can click stop when you're done with your recording, when you see an image that looks pretty good. It takes a little bit of time for the fast Fourier transform to calculate, so don't be concerned if you don't see this sharp peak immediately. But now you can see at what frequency the sound that is produced by the windpipe is corresponding to. You can also see there are some other small peaks here. So there are some other frequencies mixed in. It's not purely one frequency. Now we can do the same thing with a tuning fork. We hit record. You can see the tuning fork is much quieter, so the intensity is much smaller. We can adjust the scale on the y-axis here, like we did for the windpipe, but in the opposite direction. And we can see that there's a different frequency for the tuning fork than for the windpipe. Now, interestingly, if we use a string instrument that is not correctly tuned, we will see a different sort of pattern. So if we hit record, we can see that there are frequencies that are displayed all across this range, all these different peaks here. Whereas for the properly tuned instruments, we saw one unique peak. Here for these strings, because they're not tuned to one of the harmonics, we see lots of different frequencies mixed in, which is why it tends to sound less pleasing to the ear. If you want to view the waveform of your sound sample alongside your Fourier transform, you can simply select the graph icon on the right-hand side, select your measurement sound intensity, and select time here as your x-axis, and then you hit record. You can see, probably will have to adjust the scale of your x-axis in order to see the frequency. But when you expand the graph, you will see a sine wave whose frequency corresponds to the frequency of maximum sound intensity on your Fourier transform.